Mesdames et messieurs, bienvenue pour cette dernière journée de la préconférence.
Ladies and gentlemen, welcome to the last day of this conference, Water, Megacities and Global Change. It is a pleasure for me to inform you that yesterday we beat a new record for our event with the 1,106 direct connections and a total of 1,250 signed up. The first session of the day, Technical Solutions and Technologies, will be starting now. May I remind you of the rules of the workings of this conference? Our listeners on Zoom choose the language of interpretation, English or French, by clicking on the interpretation button in the form of a globe in the band below. It is then recommended not to change languages in the course of the session. Our listeners on YouTube will choose the link towards the language of their choice. And in the course of the session, the moderator and the speakers will be allowed to take the floor. The listeners will be able to ask questions and comments through the chat and specifying to whom they are addressing their question or comment. For everything related to the quality of the broadcasting, please address yourself to the technician through the chat. We wish you a very good conference. Mr. Benjamin Gestin, the moderator of the session, you have the floor, sir.
Bonjour à tous. Good afternoon, everyone.
Good
My name
morning.
is Benjamin Gestin. I'm General Manager at Eau de Paris. Eau de Paris is the Paris City drinking water utility, public utilities. I'm very happy to be with you today. And we have a fascinating session coming up right now on technical and technological solutions. Technology does not always mean progress, but we will see with the three examples that we will discuss today that it can be very helpful to manage better, in a better way, sanitation and drinking water systems. I'm very pleased to introduce very briefly our four speakers this afternoon. We've got very distinguished panelists. The first one to speak will be Ms. Katia Chancibaud. She's a researcher at the Gustave Eiffel University and works in the beautiful city of Nantes. Then we will have Ms. Anna Margareta Lewis. She holds a PhD from Cranfield University in the UK and works for EPAL, which is the biggest drinking water utility in Portugal. And she will have a very fascinating presentation about resilience in the Apple drinking water system. And our last two panelists will be from Poland, and I'm very pleased to welcome Mr. Jarostowicz and Mr. Zalewski from the beautiful city of Lodz, and they will speak to us about the way nature-based solutions can be implemented in major cities such as Lodz. I won't be longer in introducing this session, and I give the floor to Madame Chancibaud. Katia, the floor is yours for 15 minutes, please.
Bonjour, merci Benjamin.
Thank you, Benjamin. Yes, indeed, I'll be presenting to you the work that have consisted in reconstructing while simplifying the sewerage network at the scale of Greater Paris. This is the work, the fruit of a collaboration between researchers, but also managers of this network. Next slide, please. So very quickly, after an introduction, I will present the study area, the way it works, and the tool that we've developed for this purpose, for this reconstruction. And then I will give you the results that we have obtained, the evaluation results, and some elements of discussion before concluding. Next slide, please. So we know that urbanization is growing in the last decades and will continue to grow in the coming decades. And this urbanization through the surfaces that are impermeabilized affect the cycle of water with the resulting greater floods, intensifying also low water periods, making them longer, and limiting groundwater recharge. So the decision makers, urban planners, have a certain number of solutions before them to face up to these effects. And most have the intervention of vegetation, find the functionality of a soil, even in urban areas that is more conducive to the requirements. So there are tools, digital tools hydraulic models to evaluate the future projects that will use these lasting solutions. New modeling tools have to be taken into account, and they will bring in all the elements of the water cycle, even in the urban areas. So the modeling today means there's a total hydrographic cycle over a whole territory, which is coherent in its density with the spatial resolution of the hydrological model, which is akin to the size of the scale of the area studied. Here you have the study area, which consists in that of Greater Paris in this case. Well, it's actually city of Paris with three departments that surround it. And at this scale, the sanitation system is managed at the level of Greater Paris with the interdepartmental network, which manages the interdepartmental network, as well as five wastewater treatment plants. So the idea is to transfer water to these wastewater treatment plants. Now, this departmental at the scale of this territory, we also have two other networks, the departmental network and the municipal network. The municipal network connects the effluents locally, transfers them to the departmental network, which is itself connected to the interdepartmental network. And we are looking at several points, a system, combined system for the more recent zones as well. And in numerous points, we have zones where we have mixed systems that mix the unitary system and the separated system, the combined and the separate systems. Now, in some pipes, effluents can flow in both directions depending on the requirements of the management of the sanitation, and some of the connectors can be used for temporary storage, some of the larger pipes. And there are numerous lift stations and combined sewer overflows. So very quickly, how does the zone actually function? We have a water treatment plant on top in the image, which is the Seine downstream, draining the water of Seine-Saint-Denis, Eau-de-Seine, and north of Paris and south of Paris. Following slide, please. And we have water of the Val de Marne, which are drained through the water treatment plants in the downstream, but one part can actually be redirected into the northeast towards the water treatment plant of the Seine in the downstream. Now, if the sanitation systems are more and more topographically connected they're connected in terms of the data, but topographically, you don't really know the relationship between the different objects of the same system, although visually everything seems to be connected. So we had to develop a tool for the reconstruction of a hydrographic network, a complete one, according to the graph and arborescence, to be used in hydrological models, but also for analysis. So here you have a complete hydrographic network because we have represented all types of networks, combined and separate. We use the both vectoral and raster approaches, and the goal is to build a network which has the same functionality as a real network, although it is simplified, basing itself on a meshed grid linked normally with the hydrological mapping. So we've identified that in mesh, the runoff can enter into a network combined or separate, and these can be connected for the combined or separate networks towards the water treatment plant and natural milieu for storm water, and for rainwater, going towards the natural milieu. Next slide, please. So the reconstructed network will build the nodes, the manholes rather, of the real system, and then these nodes will be connected to the connectors of the real network. The reconstruction means that you have a set of violet colored nodes for the combined system and green for rainwater, and these are the manholes for the real network, and then the rainwater ones are used when we use one single view per square, as you can see, and then we exclude these mesh, and then we look at the same with the combined system. And then finally, we do the same thing for wastewater, excluding the mesh, which are already in the combined system. So this gives you a set of nodes, which will be the reconstructed hydrographic network nodes with special storm water collectors, depending on the requirements. So the idea is to connect the network, the nodes amongst each other, depending on a certain number of constraints. The slope we choose, the largest slope, the distance between the nodes, try to connect to closest nodes, and the aim is that for the combined and wastewater network is to come as close as possible to the wastewater processing plant. And we do the same thing for rainwater, but this time we try to come closer to the waterways that are present in the area. We then project it onto a grid, and for this we choose a certain number of outlets. And for each mesh of the network, we can link it to its direct outlet, and we can associate it to each outlet a downstream outlet. And therefore, this gives you the delineation of the catchments. So when you apply the TOHR tool to the study area of Greater Paris, we have chosen to use only the interdepartmental and departmental networks, given the resolution of the grid that you're using, that is 150 meters. We first constructed the interdepartmental network, and then each departmental network at a time, but they're every time connected to the interdepartmental network. And then we merged the built networks together so that we only had one in the end, and then we selected a certain number of outlets depending on the available hydrometric data that has been supplied to us, and also as a function of the quality of the rebuilt upstream network. Next slide, please. And thus, on this map, you have the reconstructed networks on the right-hand side for stormwater, and on the left for the combined network and wastewater network. Next slide, please. And you can assess this kind of network through a visual comparison, rebuilt and a real network between the two. And here you have the example of the Seine-Saint-Denis network. On the left, the real network, and at the right-hand side, the rebuilt one. Now, if the comparison is difficult for the combined network, so you can't see all the connections, all the meshes, but on the peripheral area, the comparison is satisfactory and easy because the separate system is not meshed together. And then here you have the drained areas through the different outlets. Here, the city of Paris has provided drained areas on certain number of the points of the network for rainwater, stormwater, and reconstructed network on the right. In certain zones to the east of Paris, but also to the south of Paris, you can see the reconstruction is not satisfactory. However, for other zones, we do have a much better comparison. As this tool actually allows us to provide data that it will allow us to analyze the functioning of the whole zone. On the left, you see the drained areas for stormwater. In blue, directly drained by the Seine downstream of Marne at the level of the confluence. And in color, you have the stormwater, which are drained this time by a combined system, so wastewater treatment plant. And the color is according to the outlets that are chosen. Next slide, please. We can go a little further in the analysis of the functioning. Here you can see on the left-hand side the catchment. I'm sorry, the quality on the screen is not very good, but you see the catchment area P117, which is on the green, the darkest green on the left, where you see the normal flows of the effluents in this combined catchment area. And when you look on the right and you activate a mesh, you see that water to the south of the Seine are redirected. Now, if we activate another sort of meshing or connection, it contributes to the P917 basin, which is in yellow, while parts of the effluents go towards the south of the Seine. So to conclude, we have developed a reconstruction tool for a full hydrographic network for a territory, which includes a sanitation system, but also the connections to the river network. Now, this tool is based on available data from most of the urban data banks, the manholes, the pipes, the altitude, and the sewer type. And we need a very good understanding of the sewer functioning beforehand and the link with the sewer management teams. And so the sewerage network is rebuilt in the Greater Paris scale. It is simplified depending on the resolution that was required. However, we have shown that it was functional, except for some zone in the Paris region where it was a little more complicated. The projection of the whole hydrographic network shows you the impact of the CSO on the drained areas, an impact of a mesh network on the drained area, and these data are available today for the hydroclimate model. Hydroclimate modeling that was accepted for Omega 2020 and has been put off till Omega 2021, so it'll be presented at that time. So we're heading towards tools which better allow us to assess the hydroclimate evolution of developed projects with the NBA, especially those founded on nature. Thank you very much.
Katja, for this very, very insightful presentation. Thank you for respecting the time frame that was defined for your presentation. I guess there will be lots of questions about what you just presented, but we'll have a Q&A session at the end of the hour we have to spend together. And I give the floor right now to Anna Margarita from EPAL. The floor is yours for 50 minutes, please.
Thank you very much. It's really a pleasure to be here. Next slide, please. Okay, so I tell you a little bit about EPAL, then I present the integrated risk framework we developed in EPAL. I'll show you how smart technologies act as various strategic risks, and we'll highlight how the important role of foresight analysis. Next, please. Next. Okay, so EPAL is a company founded in 1868, so very ancient company. We supply drinking water to around 3 million inhabitants. And since 2015, we are also responsible to manage the concession of another water and wastewater company that you can see there over there in the map. And altogether, we now serve around 4 million people in Portugal. That accounts around for around 40% of the Portuguese population. Next, please. Okay, now, if we go back to 2010, we wanted to know what were our current and future vulnerabilities. And really, when we looked into the existing frameworks, we weren't quite happy because most of them relied on Excel spreadsheets, and in the end, we came up with a number, like in the causal framework or a color. And so we went to Cranfield University, we spoke to Professor Simon Pollard, and we decided to develop a new methodology. Actually, it was my PhD, and it is entitled Strategic Risk Management in Water Utilities, Development of Holistic Approach Linking Risks and Futures. And the supervisor was Professor Simon Pollard. So this holistic approach comprises mainly two phases. Next, please. And next, the first phase intends to assess the strategic risks in the present. And the second phase is to understand how those strategic risks might evolve in the mid and long term. In the first phase, we begin by identifying the strategic objectives of the company. Then we developed a systemic model. And finally, we can compare the strategic risks side by side. And we have a look now in the next slide, please. Next. Okay, so on the right, you can see, the previous one, please. Previous slide. This one. Okay, thank you. So on right here, okay. On the left, on the right, you can see the strategic objectives that were identified for EPAL. It is to secure the business sustainability and profitability, then to supply water with enough quality, reliability, and quantity, and also to ensure the reputation and trust of the company. And the strategic risks you see over there are just the risks of not meeting those strategic objectives. So once we know our strategic objectives, in order to assess the strategic risks, we went to see what could pose harms to those strategic objectives. And then we identified the events that can lead to those harms, and also we assessed the way we are exposed to those events. And having reached this phase, then we went to see what barriers, what procedures, what tools we had in place that would lower the likelihood of those harms from happening or lower the consequences of those harms should they happen. Next slide, please. And the next step, we assess the robustness of each of those barriers, the effectiveness of them. And doing that, and also assessing the likelihood of those events, we can assess the likelihood of the exposures and the likelihood of the harms, and finally the likelihood of the strategic risks. So we can here in a single picture understand our strategic risks, the likelihood of the associated with the strategic risks. For example, you can see that we have two low likelihood risks, like water quantity and water quality, but these two green strategic risks are different in nature. You can see in the bottom that the risk of supplying water with inadequate water quantity is low, but it's naturally not low from the event's exposure harms. But supplying water with adequate water quality, it's only low due to the barriers we have in place. And so the essence of risk management is truly keeping those barriers effective and robust. Next, please. And then if we combine the likelihood of the risks with their consequence, should they happen, then we can compare, and we have the heat map with our strategic risks side by side as we intended to. But because the strategic objectives are set for the long term, we also want, and our master plan is for the next 30 years, we wanted to assess how these risks could evolve in the future. So next, please. We began by characterizing some megatrends, known megatrends like climate change or trunk mains deterioration over time. And then we added some key drivers and constructed future scenarios. And then we reevaluated the strategic risks under those scenarios. Please, next. Okay, so we use the cross-consistency analysis to build future scenarios. Those are some of the key drivers we use: the state of the economy, energy prices, consumption, water quality, water availability, and so on. And each of those lines, they represent a consistent story of how the future might develop. And actually, that's the definition of a future scenario. Next, please. So for each line, for each scenario, we wrote a narrative. And that narrative took into account the specific context of EPAL. Next, please. So we had before the strategic risks characterization in the present. That was our reference scenario. Next, please. And so we took, for example, the water scarcity scenario, and we reevaluated the robustness, the hypothetical robustness of our barriers under that scenario. Also, the hypothetical likelihood of the events under that scenario, and with that narrative bearing in mind. And so we reassessed our strategic risks. And you can see, for example, the reliability, how it increases a lot. And that's what we're taking right now into account, because we are presently revising our master plan. And so we have to account for different new barriers, new adaptation measures, so that we can keep the reliability of our supply under an acceptable level of risk. Next, please. Next. Okay, so if we come to this systemic diagram, next, you can see now those red dots, all those barriers are related with smart technologies. So it's really clear how smart technologies play a fundamental role in preventing the strategic risks from happening. Next, please. And I'll give you just 3 examples. Example 1, it has to do with asset management and with the way we use GIS to prioritize the areas to be renewed in the city of Lisbon. So we have these criteria. Some of them give us the likelihood of failure of a pipe, like the age, material, number of bursts, or the consequence, the number of clients affected if the burst occurs. So that gives us the risk of a pipe failure. And also we combine it with the costs. We have this indicator that compares the cost of renewal with the cost of repairing. And we put all that, next please, in our GIS. And so each section will be given a color. And so the sections that are colored red or orange, they are the ones with the highest priority to be renewed. Next, please. Then we also use we use GIS to identify the areas of highest concentration of red and orange sections. Next, please. And so these are the areas that within the next years will be renewed in our city of Lisbon. Next, please. Okay, example number 2 has to do with smart work management. Can you give 5 clicks, please? So except for SCADA, which is really a technology that's, well, I don't have to talk about SCADA, the importance of the role of SCADA in managing a system, a water system, but all the other tools have been developed in-house. So we have a tool for actively to help us to actively leakage control or customer relationship or water management. And so all of these help us to manage in a better way our system. In the third example, next please, has to do with a set of contingency and emergency plans that we have in place. Next, please. Okay, now about the Foresight analysis. And I told you before that climate change is a fundamental mega trend that we have to know in order to deliver our future analysis. So next, also, regarding climate change, and back to, again, 2010, 2011, we knew our current vulnerability to climate change was low, and that was mainly due to natural conditions of our main water source. You can see over there that big reservoir, but also due to some adaptation measures that have already been taken in the past. But also we wanted to know how our vulnerability in the future would be to climate change. So next slide, please. We set this Adapta Clima project. We assembled this team with 4 Portuguese universities and also together with an internal team. This is very important, to work together with universities, but also with an internal team. And so the researchers did all this modeling about water quality, water quantity, and then together we assessed the impacts of the results of that modeling in our system. And we came to the conclusion, next please, that our future vulnerability was low to medium, which is good. But still, we decided to implement, next please, a flexible adaptation plan. Now you can just click till the end of the slide. And so some measures were already in place. Some measures, can you click, please? Some measures are foreseen for the midterm and some measures for the long term. Can you click again, please? Can just click more times. The measures for the long term are only foreseen in case the worst scenarios will happen, and like the desalination plant in Lisbon or a new spur in Tagus River. So these are very hard measures, and we didn't want to anticipate unnecessary investments, but the key question is, when should we build them? They should be in place when we need them. So to answer this question, we identified some climate change indicators, like the ones you can see here. So every 3 months, we monitor these indicators. So far, it's been all green. But the moment we start getting yellows or reds, then we'll have to think about additional measures. Next, please. So to conclude, regarding the strategic risk management approach, it represents the first approach combining risk and futures. Next, it allows the company to have an integrated view of its strategic risks with an influence diagram. It shows the role of smart technologies in securing the corporate strategic objectives. It allows the company to anticipate how strategic risks might change in the mid and long term and to timely adopt adaptation measures. And it provides the basis for the utility master plan. There is this Chinese proverb that says that happiness in your life doesn't depend so much on the game you have on your hands, but on the way you play your cards. But for utilities like ours, they are assets intensive and depend on assets. That's not true. So the way you plan it and you do the things at first time, it will really set the game for the future. So it really must be well planned. And this is the reason why this approach was awarded by the IWAPI Project Innovation Awards and also by the Portuguese Association of Water Resources. So final remarks. Both the strategic risk management approach and the Adapta Clima project are successful examples of collaboration between industry and research. Next, this approach is aligned with the European Commission's first strategic forward-looking report in order to guide the necessary transitions in a sustainable way and keeping strategic risks at acceptable levels. And finally, we strongly believe this approach can be adopted by other entities with management roles in megacities, contributing to leverage their pathway towards resilience, and ultimately we'll all end up like this chap over here. So that's all. Thank you very much for your attention.
Thank you very much, Ana Margarida. Thank you for respecting the time frame, and thank you for this very interesting presentation about how technologies can fit into a broad forward-looking approach of risk and risk management in the future. Thank you very much. I'll give the floor without any further transition to our friends from Poland, to Mrs. Rosjewicz and Mrs. Zalewski for 50 minutes for their presentation about nature-based solutions in blocks. The floor is yours, Mrs.
Thank you, Mr. Chairman. Good afternoon. I think one of the biggest challenges to achieve sustainable development goal are megacities, because more than half of population lives in these megacities, and this number is still growing. So the challenge is how to improve quality of life citizens in megacities while reducing the impact. And this map, World in the Night, is showing how the megacities are distributed, and they are how important, how we're using energy, fossil fuel energy right now mostly. However, also we see how are distributed the space when water cycling is modified by this megacity surrounding area and by process of urban sprawl. So as an answer to the question, I think we would like to say that the future is intelligent blue-green city, which just by putting intelligent, it means new technology to reduce emission of pollutants per capita, and blue-green city improving the quality of life health, which prevent urban sprawl, which is degrading surrounding environments. Next slide, please. So, and on the beginning, we have to really start to appreciate more the role of ecosystem water cycling, recharge groundwater. And this is showing the map, how not exactly the same pathways of distribution. Red area, which means that ecosystem in 90% recycling the water. The blue area, it's showing the oceanic influences on the precipitation are dominant. However, the climate change are increasing very much the catastrophic events, floods, storms, and definitely this is a beginning because we are facing 1 degree increase of temperature increase, global temperature increase, and we have to expect, let's hope, 1.5. So still rather exponential trends in some aspect, especially floods increase. Next slide, please. And what we do is megacity. We just accelerate river outflow from megacity, from the catchments. So the amount of water become more stochastic, which is provided to the catchment, and we are sending fast as possible to the sea. So rather, it's not really wise, and we have to think how to convert the threats from the storm into opportunities for the quality of life in the city. Next slide, please. This, on the beginning, we need to change the paradigm. We are living in sociocentric and mechanistic, when really progressing degradation is very fast. Ecological footprint is 1.7, which means a 70% exceeding regenerative potential. We have to start to think evolutionary ecosystemic. Evolutionary, we have to keep in mind that biosphere is permanent evolution, and now humans are a major driver of this evolution, and ecosystemic as a reference point for shaping our space, and especially megacity. We should keep in mind how the water cycling, nutrient cycling, energy flow is organized in the ecosystems. Next slide, please. And 3 principles, ECOHYDROLOGY somehow should be helpful, because the first is hydrological cycling. It is showing how we are for catchment in this moment identified dispersed pollution on the left, mathematical model of nitrogen phosphorus pollution area. Next, sewage treatment plant, and this was a background to develop the intelligent ecosystem concept, when we're showing that further homogenization terrestrial water landscape force us to think about enhancement sustainability potential of ecosystem by regulation interplay between abiotic, hydrological, and biotic ecosystemic process. Next slide, please. And now we have a choice. If we are just according mechanistic vision, we'll shape the city on the left when we're degrading water, biodiversity, services for society, resilience to climate change, which also affects culture and education in a negative way, or we will create blue-green city, intelligent blue city, when we can, by interplay, understanding of ecosystem and interplay between water and ecosystem, enhance water resources quality, especially convert stormwater in the water in the city landscape, which somehow reduce the impact change, biodiversity, services for society, resilience to climate change, and in turn, cultural education. And I think this is a first step. And next, I would like to give the floor to my colleague, Dr. Jaroszewicz.
Thank you, Professor. Thank you, Professor. And welcome, everyone. Next slide, I would like to ask. So after this holistic background, in the second part of our presentation, I would like to show you the case study of Łódź city, which is located in central Poland with environmental problems similar to all of the urban areas worldwide. So locally performed climatological studies have revealed that there is a close association between density of urban development and heat island effect in the city, where the difference can reach even more than 10 degrees between city center and less urbanized areas. Next, please. Moreover, studies performed in cooperation with medical school indicated the correlation between concentration of alpha-benzopyrene, and this is air pollutant, and rate of impermeable surface, with the biggest pollution in areas with limited blue-green infrastructure. Moreover, this correlation has the reflection in the residents' health. When compared asthma and allergy among children in Łódź city, they found a huge difference between center and suburban areas. So we need to remember that the one grown tree can evaporate up to a half cubic meter of water per day, which increases the air humidity and reduces concentration of dust and pollution. Next, please. And the most visible problem observed particularly during heavy rainfall events in Łódź city, and after taking this picture in 2018, Polish internet have showed a huge creativity potential by making conspiracy theories about first city in Poland with program of submarines. Nevertheless, it is still an extremely serious problem, generating huge infrastructure damage and decreasing the water quality. Next, please. Fortunately, in Łódź city, there are two ecohydrological centers, one on the University of Łódź and the second in the Institute of Polish Academy of Sciences. Within the framework of ecohydrology and WBSRC concept, a blue-green network has been proposed first time. This idea was to connect the small river corridors in Łódź by recreating a network of blue-green areas that could be in a walking distance from each citizen in the city. As the municipal government was very enthusiastic with this project, the team of ecohydrologists under lead of Professor Zalewski and Professor Tomasz Jurczak has obtained a project from European Commission LIFE program. Project have been implemented in one of the blue-green network concept areas you can see marked on the map. This is an upper Bzura River catchment. What is most important, this area serves as a recreational space for a huge part of city inhabitants, providing multiple ecosystem services. Next, please. Yet, due to the impact of pollution and altered hydrological cycle, as you can see on the left part of the slide, those reservoirs have faced a toxic algae blooms each year, limiting their ecosystem services for local society. After the identification of threats, which is a first principle of ecohydrology approach, as you remember, and analysis of ecological processes taking place in the area, which is the second principle, the implementation phase could start. Based on the third principle of ecohydrology, so-called hybrid systems have been proposed, which are integrating the engineering approach and nature-based solutions, creating sustainable technologies with very high efficiency. And as you can see, total suspended solids have been reduced from the level of 165 to only 3.4 milligrams per liter with a single technology of hybrid system. Next, please. This high level of efficiency was a result of ecohydrological nature-based solutions development. Those solutions provide a low-cost way of water purification in the urban areas, and they open the possibility for safe water retention inside the city. The example of such technology is a sequential sedimentation biofiltration system, as you can see on the picture, where by using the natural processes, not only high efficiency can be achieved, but also there is a space for natural succession. And thanks to the high biodiversity, they are resilient, resistant to the external stress. Some of the technological advances are geochemical barriers to trap the pollutants, or bed regeneration system that increases the durability and efficiency of such constructed system, which is still effectively working after 13 years of operation. And next, please. Although we can get a high efficiency of eco-hydrological solutions in urban space, we continue our endeavors to develop even more advanced solutions and technologies. Recently, during my PhD studies, we have elaborated an innovative material efficient in phosphate removal, but also ready for the plant growth support and promoting growth of helpful microorganisms in the environment. We've been able to achieve that thanks to the construction of material where we use nature-based components such as clay aggregates and biopolymers. Next, please. Here on my hands, you can see some alternatives of biocare made with calcite and activated carbon. And with this technology development, I am always thinking very warm about Paris. Perhaps thanks to the International Innovation Concours Le Pen, where the technology was awarded with a gold medal. Next, please. From this point 2 years ago, our technology has progressed towards the integration of nature-based solutions with circular economy. How to do it? First of all, the core of biocare is a resistant and environmental safe component. We use a specifically designed mixer to integrate all of the components and create final product. And this product is able to trap the phosphorus in the flowing water. So we can implement this, and by catching this phosphorus, we can create a fertilizer. Then the fertilizer can be used for the plant growth in hydroponic systems or traditional ones, and the core material can be reused again. This is how we close the cycle of phosphorus in the open ecosystems in the city. Next, please. As the result of ecohydrology implementation in Łódź, reservoirs quality have been significantly improved and ecosystem services rebuilt with strong support of WBSRC goals. In the result of this great success, the European Commission has awarded this LIFE project, ECHREC, with an award, Best of the Best. Next, please. Now, up to the conclusions, we would like to emphasize that cities should become a key actors in the global impact reduction and climate adaptation. This can be achieved with the development of international network where information, knowledge, and innovations are shared. And as we know so far, UNESCO is fulfilling this mission with devotion, and we are supporting, of course. In the end, City of Future should be a synergistic system supporting high quality of life, culture, and education. Next, please. Yes, and exactly the way forward for the ecohydrology and sustainable megacities development is related, first of all, to the alliance of environment, engineering, economy, and society. But it should be supported with emerging fields such as artificial intelligence as a basis for smart network management, or big data analysis, or citizen science, generating the involvement of the society. Next, please. And in the end, I would like to thank you for your attention. And if you are interested in ecohydrology, we encourage you to look for the ecohydrology program of UNESCO Intergovernmental Hydrological Program with a global network of cooperation. Also, you can read about ecohydrology in the Journal of Ecohydrology and Hydrobiology, where Professor Maciej Zalewski is editor-in-chief, and I am serving as assistant editor. Thank you once again.
Thank you very much, Professor Zalewski and Dr. Jarosevich. Thank you very much for this very insightful presentation. We've got 50 minutes of discussion now before we end our panel session. We will have questions from the floor, I'm sure, but I will start with one question addressed to our Polish friends and also to Katia Chancibo. You both share a very theoretical approach on the way you deal with urban waters. What are the main challenges you will face, the local decision makers will face when implementing these ideas and concepts and tools into practice? What are the big implementation challenges? I don't know who would like to start answering that. Maybe Professor Zaleski? With your mic on, please.
I think I was impressed by all presentation before our presentation, because it's giving a kind of background for holistic approach. And then I think integration of the first presentation, second Portuguese approach, which was very near to us, also holistic way of looking to putting together the puzzles. We can create really the city of the future, which will be already what we said, friendly for people and reducing impact for biosphere, which is our implicit goal of everybody, I presume. Thanks.
Thank you very much. Katia Chancibo, maybe I'll answer the question in French, would be easier. Les obstacles, de votre point de vue, de chercheuse, pour la mise en œuvre d'un modèle comme celui que vous construisez avec l'outil TOHR. Quels seraient, d'après vous, les obstacles pour l'utilisation concrète d'un outil comme celui que vous avez construit avec l'outil TOHR?
The difficulty, I would say, with this tool is really what we found on the Paris region, which has a management of its network, which is very complex. And that is what I was indicating in the beginning, is the number of storage points that exist and that are varied, whether it's basins or hemispheres. And so we are now taking this into account into the tool so that they can be taken into account in the modeling. And also in terms of the direction of the flow, which can be in both directions in a network, in the framework of these automatic tools. So that is something that is complex. So technical obstacles and that of complex governance.
Du coup, sur les questions de gouvernance, est-ce que vous avez appliqué ce modèle TOHR à un territoire peut-être différent de celui de l'agglomération parisienne, qui est particulièrement compliqué?
To a territory different to the Paris region, which is complicated? Yes, within the framework of a thesis applied to the territory of Nantes. So we looked at a smaller zone. We didn't even actually work at the scale of the whole city of Nantes. The management is simpler. For example, we don't have the connection of the combined towards wastewater, just wastewater to the combined system. And we had the tool evolve, of course, when we started working on the Paris region. And today we're back in the North region to work at the scale of the whole conglomeration and with the urban planning documents.
Perhaps a question now for Ana Margarida. You have emphasized the fact that you work upon a lot of research, and that research is conducted internally or done by yourself, by EPAL, for a major part of it. Why did you do that choice? Why did you choose to do your research internally? With your mic on.
Okay, so it was not quite a decision. It was a decision, but first the idea came from the CEO of EPAL in 2010. And so my role was to say yes. And it was quite an effort, because I still kept my duties at EPAL at the time. And I did the PhD keeping the roles at the same time. But also it was, I recommend to everyone who can do the same, and to every companies, whoever is listening to us over here, because it's really, it brings a lot of benefits for the company, because the know-how stays in house, and it does not stay only with me, because this involves the whole team. This holistic approach involved many risk experts from all the departments, because even from the reputation, communication, the marketing, even the ones you wouldn't expect to be involved, but they were all involved. And the risk management, the concept of risk is ingrained now at EPAL. It wasn't at that time. So it's really beneficial, not only for the person who does the PhD, for myself, but for the company as a whole. And that's something I would definitely recommend. And in the climate change project, I can also share with you that there was a phase of the project where we relied, the first phases, we relied only on the researchers, and they didn't have the knowledge of the company. And so what were our values, the trade-offs we were willing to take. And if we weren't part of the team along the project, in the end, we would come up with some results that wouldn't fit our purposes. So working together, the technicians of the companies with the researchers, it's strongly beneficial, and I would recommend it to everyone.
Thank you very much for this answer. Maybe one more question for you from the floor. How do you decide upon the trade-offs between your various strategic objectives, whether it is water quality, water quantity, profitability, sustainability of the business? How do you deal with these choices you have to make at the level of EPAL and in coordination with local authorities?
Right. Well, first of all, between the different strategic risks, we set acceptable levels for each of them. And so the question of the trade-off didn't quite arose, because if any of those strategic objectives were in danger of not being met, we had to set the necessary measures for them to come to an acceptable level. So it wasn't really a question of trade-off, but we want to ensure all of them were kept at an acceptable level. With the other official entities, that's quite a question because it requires overall governance that doesn't depend on ourselves only. It depends on all of the authorities that act on the river basin, for example. And well, the straight answer to that question is we try to be on the safe side. So because we didn't control the pollution that comes to our water intake in the Tagus River, for example, we took the decision of investing around 13 million euros in refurbishing our water treatment plant there, because we could not assure that the water quality in the Tagus River, in that section where we have the intake, would be kept at acceptable levels. So we decided to increase our barriers downstream. Maybe, not maybe, the real thing, the pollution should be kept away upstream, our intake, but because it's not really happening, we reinforced our downstream, the things that are under our control. But that's really something that's here in Portugal. We're trying hard to work together with the environmental agency and all the other players in the river basin.
Thank you very much. One more question for Dr. Jaroszewicz. We can notice from your presentation that you need to use a lot of land to implement your concept of eco-hydrological management of urban waters. How do you manage the land owning aspects of your policy? How do you manage to control the land in such dense and rare territories such as inner cities?
Thank you for this question. Yes, actually, it's one of the huge challenges for us to create the resilient city of future. However, we must remember that application of eco-hydrology and blue-green infrastructure to create such blue-green network in the city is not only related to the large-scale investments. It's also related to some very small distributed retention of water measures, or green roofs, or green walls of changing the management of water in really very local scale. And only with such distributed approach around all the city, we can create some real important change in the whole city scale. However, of course, these kind of investments, we may think that they need a lot of space. However, as we showed during our presentation, we propose also so-called hybrid systems. This means that those systems can take much less space and have still very high or even higher efficiency than the traditional approach. So only in the first picture, it seems like we need a lot of space. But then if we think more and we make more focus inside the city area, we understand that it's really easy to find such places around the city.
Thank you very much for this.
One sentence, if I can add, you know, the system first, which we show, has, by comparison with constructed wetland, which needs 1 to 3% of the catchment to purify the water. This needs 0.3% of catchment surface. So it's much more compressed and efficiency is much higher. Thanks.
Thank you very much. Maybe to sum up all the discussions we had and all the examples you've showed us. One question for everyone, and we'll answer with whomever wants to answer. Is there a choice to be made between technological solutions and nature-based solutions, or do we have to think about combining them? So maybe I would like to hear Ana Margareta on this very broad question. Do we have to choose between technology and more nature-based or governance-based solutions to respond to the challenges we have to face?
I don't think we have to choose. I think they should be used in combination. And one of the things this strategic planning tool enables us is when we are thinking about solutions for the next 30 years, it's the right moment to think about this combination. Because once you implement the hard measures, the technological, then you already invested the capital. And if they are centralized solutions, then it's much more difficult to decentralize or use more nature-based solutions afterwards. So it's not a question of choice, but it's a question of using them in combination. And the planning time, it's the right moment to do that.
Thank you very much. Professor Zaleski, I saw you were shaking your head.
Yes, I have ad vocem. I think we need to use holistic approach and combine the knowledge from first presentation. Next step, holistic, putting together different technology, methodology, plus nature-based solution. And this is something which needs to make an effort. And I think UNESCO is excellent organization, which is encouraging this type of cooperation as this symposium. Thank you very much.
Thank you very much. Katia Chancibaud, peut-être une réflexion, un commentaire sur cette idée de combiner des solutions très technologiques et très naturelles.
Yes, I think I would also go in the same direction as combining the different types of solutions, the importance of those solutions based on nature, and that they offer benefits in many other fields. We spoke about strategies without regret. These are solutions which allow the improving the mental health, the well-being, the physical health, and social cohesion of dwellers, of people. But of course, probably technology would help too.
Thank you very much. Thank you. I think we can all agree about the necessity to combine both technologically based solutions and nature-based solutions. And I would like to add, because that's more of my day-to-day work, that governance issues are also to be mingled and mixed within that blend of technology and nature-based solutions. So I think we've reached the end of the time that was allotted to us for this session. I would like to thank very warmly our 4 speakers and thank them for their very insightful presentations and very complementary with different approaches and different examples in different geographical contexts. And I hope everyone was interested in listening to this presentation. And I thank all our auditors for participating in our session. Thank you very much to everyone. And I'll give the floor to the next session, the next panelists and net moderators. Thank you very much to everyone.
Do we start now or do we wait for?
Mesdames et messieurs, notre seconde session du jour.
Ladies and gentlemen, the second session for today, New Water Culture, will start. Pierre-Alain Roche will be moderating. Thank you, and thank you to all for being with us here today. Just a few words by way of introduction. I hope that you can all hear the interpretation into English properly, as I will be speaking French, says the moderator. So we will have three presentations, three 15-minute presentations, and 20 minutes will be available for Q&A with all the participants through the chat. And we will ensure that questions asked in the chat are asked to our speakers. The topic for this session is new water culture. This is very ambitious, quite an ambitious goal, and we will, of course, only broach the issue superficially with the three presentations. Not that the presentations are superficial, but we will have a quick insight into this issue, an issue that is very topical, new and upcoming water culture. So we will talk about port cities, urban planning with Carola Hein. Then we will look at a collective work by Felicia Marcus, who is with us despite the fact that she's in a completely different time zone. And then we'll talk a specific case where there's a very high technology issue at stake. And so we will talk about an innovation which raises a number of questions in terms of ownership. So that's a quick outline of these three presentations. I will now give the floor to Carola Hein, the water wheel, a socio-spatial method for understanding and displaying holistic water systems.
So, Carola, it's yours. You have the floor.
Thank you very much for the presentation and for the organization of this excellent session. I would like to talk today about the proposal of a water wheel as a socio-spatial method for understanding and displaying holistic water systems. The idea is that many megacities around the world are located in urban deltas, and that's where the possibilities of shipping and of the availability of flat lands has attracted a lot of people with industries, businesses. And these are areas that have historically had a strong attraction to people around the world. Now, in these areas, we have multiple water problems or challenges in the same space. So if you go to the next slide, please. So the questions that we find there are lots of diverse water challenges. We are talking about clean drinking water, sewage water, subsidence, delivery of water for agricultural and industrial purposes, issues of land reclamation from the sea for agriculture and construction, but also fighting the rising sea levels or salination or the need to keep waterways and ports open for shipping. Now, all of these water-related problems are interconnected and they require multiple stakeholders to work together at diverse scales. So we're talking about port authorities, municipalities, regional, national governments, each of them with their own needs, ideas, and values attached to this. Now, port cities have through the ages been very resilient and they have dealt with numerous challenges, from flooding to earthquakes, from strikes to other types of challenges. Now, in each of these cases, they have, well, I'm still one slide back, but that's okay. In each of these cases, they have been able to bring together diverse stakeholders to collaboratively direct the urban planning and the development in a way that focused, that brought forward the opportunities of port cities in the long term. So what I would like to do in this presentation is briefly talk to you about resilience, because I would argue that port cities are particularly resilient types of cities. I would then like to introduce the water wheel methodology as a way to look at big data of the past to better design the future, and give you a few examples from 3 cities that we've been looking at so far, with the goal to make the transformation of each of these cities comparable through time and in space. So next slide, please. So the issues that we are dealing with in terms of water are multiple, and it's very difficult to bring them together in a single frame. Now, all of these different issues occur concurrently in space, and that is why we think that looking at them through a spatial component, through deep mapping, as we call it, will be a way to understand how space, society, and culture actually overlap. Next slide, please. So when we think about port cities around the world, can you go to the next slide, please? Can you hear me? Sorry, there's a no, so back one more slide to the resilience slide. Sorry, there's a lag in showing it, yes. Thanks. So the question of port city and resilience is an important one. And we think of resilience often as a way of bouncing back to a level that we had before. But I think the question of resilience is a much more complex one in port cities, for example. We are talking about environmental resilience. That's after a flood coming back to an origin state, but there's also social resilience, the way in which we react to strikes, for example. There is political resilience. There's all kinds of different resilience according to specific actors. Now, what I'm interested in here is to say, what's the resilience of the couple port city region? So are there specific features where port city region actors have collaborated in the past to forward the needs of the entire group of the entire region? And we can see those kinds of events quite a number of times. For example, if you have a flood or a fire or something destroying a city, often the different stakeholders will come together and come up with new solutions in order to further the ongoing of shipping and trade. In the case of my hometown of Hamburg, for example, the fire that destroyed the city, large parts of the city in 1842, and that burned for 3 days, harbor activities would continue. And after the fire, the local stakeholders, the landowners, came together to redivide up the land in the city and in order to create new infrastructures that would facilitate trade and business. Now, those kinds of examples often show you the advantages for specific groups in the city. They might not speak of the challenges that the other citizens, for example, experience. So in many port cities, and again, to take the example of Hamburg, you might see that people are have to leave their houses, that entire neighborhoods are being cleaned to make place for different activities, for warehouses or for office districts. In many of these port cities, you will then see that often the stakeholders will intervene and come up with solutions that serve also the local stakeholders, building new housing districts, establishing infrastructures that facilitate the ways in which the people can come and return to the port where they are working. Now, this time of resilience requires a methodology that allows us to look in time and through space in a comparative way. And if you go to the next slide, please. So we've been looking at trying to find ways to make evolutionary resilience visible through a data wheel. And this data wheel aims at connecting different disciplines, different disciplinary approaches, each with their cutting edge questions and approaches. So the data wheel is based on the idea, let's look at data in the past, the way that historians work, and that would be the path that you see gray at the top right of the wheel. So looking for historical data about water, about land, about port, about cities. For example, in this case, we've been looking at historic maps and finding them in archives, as well as the socio-cultural data that goes with it. So you can think of changing boundaries of institutions. You could also think of health data, of population data, of land ownership. Now, this historical data, once collected, needs to be prepared in a way that makes it connectable and interchangeable. And that can be done by hand, but with all the new tools that we have, there are quite a number of ways to do it with crowdsourcing and even artificial intelligence. So the dark blue area speaks to the questions that computer scientists can answer and that are often even research questions for computer scientists. So for example, we've been working with colleagues to use crowdsourcing to read historical maps, so that we've been using crowdsourcing through CAPTCHAs, for example, that people who enter a website will answer a question: is this water, is this land, is this a church? And when you answer those questions correctly, the algorithms can start reading these historical maps and translating them automatically into built-up area, rural area, water, land, street, and those kinds of components. So we are really trying to teach the algorithms to learn to read historic visual documents. Now, once we have made an abstraction of historical maps that is ready to be put into a GIS-based system, we can then use quantitative or qualitative analysis. So we could look at it and say, well, how much of the area is water, how much is land, where are specific buildings located or not. So that will then allow us to go into the left side of the circle and not only analyze the geospatial data, but also cross different areas, different parts of the data, and create new maps, which in themselves then become part of this data circle that becomes part of history. I mean, keeping in mind that every map you make is an abstraction and will represent only parts of the reality. So the map itself shapes history and becomes part of it. And we've seen in the prior session a lot of geohistoric or geospatial data on water systems that have resulted from historic practices. So understanding what kind of historical water practices underlie the current condition is part of what we are trying to do. I mentioned before that we're talking about resilience. Resilience is also embedded in spatial structures. Having built specific port areas, specific dikes, or other water structures will determine how a city can respond to a disaster or intervention at a later point in time. The way that local actors have responded in the past can also determine the way in which they look at challenges for the future. This is something that the political sciences call path dependence. So we are trying with this data wheel or with this water wheel to recognize historical changes and the way in which they influence contemporary practices. So if you move to the next slide, the way that these practices are, in the way that we can analyze these historical practices is will also determine what we see. So for example, whether we study a city at a small scale, for example, at the scale of the waterfront, or we study it at different scales, but at the same moment in time. So you could imagine looking at a city in 1300 and looking at all the different scales, for example, to understand what kind of shipping or water practices were going on the waterfront, and to see how far into the region this trading would reach and where it came from. Or you could say, I want to understand how the waterfront has changed over time and see, let's think about the London Docklands, how the choice to build the Docklands has influenced the way in which we have done waterfront renewal today. Now, the approach that we have chosen so far is not temporal or scalar, but it's really one that is based on perspective. So we've opted for the diagonal perspective to see how has the land, water, port, city relationship changed over time and through space. And so you can see how the port has been growing, how the city has been growing with it, and how deep, ideally, the reach into the hinterland of this port-city relationship has been. If you go to the next one. So let me introduce a few of the cities that we've been working on so far. We have started by looking at the North Sea as our framework. And the idea is to say, how did specific cities respond to the same challenges over time? Now, shipping, by definition, is the same ship, has to reach the same ports, it swims on the same waters, and the containers are the same. So historically, are different types of containers or bags, and today we're truly talking about containers. These same containers reach the city. They start arriving in cities at a specific moment in time, and the local cities have to respond to their arrival. Now, in this mapping that you see on the screen currently, we've been looking at the ways in which London, Rotterdam, and Hamburg respectively have responded to these changes over time, and thus also to the question of their resilience. Now, in the case of Hamburg, you notably see, if it's not too small, that the institutional borders, the governance borders, have grown together with port and city. So as the city has developed, there has been one single institution bringing together port and city. And that, I think, has allowed the city government to also counterbalance the interests of a port, which has more and more grown towards facilitating global commodity flows rather than benefiting the city. So in the case of Hamburg, a place like the Hafen,
rapidly.
yes, the Hafen city has been able to grow. In the case of Rotterdam, the city tried to catch up with the port. In the case of London, the port has grown way beyond the borders of the city. Next slide, please. So to conclude, we are trying to find a way to develop a method that allows for historic understanding, the reasons why things look the way they do, a multi-scalar understanding, seeing how waterfront is connected to hinterland, and a way to really bring in multi-scalar, multi-stakeholder approaches. So we're looking for a holistic understanding that can form a foundation for contemporary and future-oriented design. Thank you very much.
Merci beaucoup pour votre présentation.
Thank you very much for this presentation. As I was saying, we're going to move on to an illustration of various situations in various countries, which is the fruit of the work of a very interesting exchange network. Felicia Marquez, it takes a team helping megacities build water security in the face of socioeconomic and climate change challenge. Felicia.
Thank you very much. I'm honored to be here on behalf of my water policy group colleagues. We're a group of current and former high-level water officials at the national or international level, and we've come together to provide company advice, etc., from a practitioner's perspective to water officials across the world. We're on 6 continents, and we do bring that practitioner's eye and experience to the myriad water policy issues that confront folks and that water officials need to make, both using their technical ability, but also their very human abilities. Our purpose in putting together this paper for this conference was to just illuminate some of the kinds of choices that national and state policymakers can make that can make a real difference to megacities that are struggling to achieve resilience to climate change in a rapidly changing world, or meeting the human right to water challenge that bedevils governments, but may well be the greatest test and challenge of our time, showing who we are as a society. There are a lot of choices to be made here, and nations and states can take a distanced role or play a certain traditional role, or they can take a more engaged role in how they choose to use the policymaking, regulatory, financial, and other tools at their disposal. And I guess the main point that we want to make, that it is as much about the attitude that policymakers choose to take as it is about any of the roles they traditionally have played. Next slide, please. So I'm going to give a bit of an introduction, and then I'm going to talk about a few case studies far more briefly than I'd like to. You can read the paper, and there will be far more color and flavor to this a year from now. 3 of the 4, it turns out, just as we submitted our examples, deal largely with issues of recycling, some stormwater capture, and the 4th, a really interesting one in eThekwini, South Africa, deals with the issues of access to clean water and sanitation. Then I'm just going to share some of the lessons learned that we've come up with and some concluding thoughts for your consideration and further reflection. It's going to be rapid, so I'm going to look forward to the conversation this morning and later. Next slide, please. You know, the most traditional role of national and state governments is to direct cities what to do. Sometimes, whether it's in water quality or in water supply, it really varies in different countries, even within different states in the US, it can vary, or in other countries. And it takes the form of policymaking or regulation, and sometimes both. It can be accompanied in the best cases with funding, of course, and sometimes the role is simply to leave the city on its own. And different governmental structures exist. Some are more top-down than others. And of course, the forms of government vary among our own examples, and there isn't time to explain all of that today. Our point is that the challenge for large cities is huge and can have an impact not only on the millions of people who live in those cities, but also on the economic and societal health and well-being of the larger states and nations. And so a strategic partnership and a joint approach to meeting the very real needs of those millions can serve the most good. Sometimes cities need a push, sometimes they need direction, sometimes they just need some help, and policy directives and regulations are important and have their place, but they need more. So for example, funding is always appreciated, but also actually having partners that understand what they're trying to do, who also think about removing the barriers they may inadvertently be placing in the way of these cities, crafting strategic regulations or policy that actually help enable the cities to do more, and really helping them and also sharing their successes among others. Next slide, please. I'm going to start with the Southern California example because it's the one I'm most familiar with, and I'll just give you a bit of the setting in California, and I won't be able to do it justice, but obviously it's the 5th largest economy in the world, larger than most nations, and it has an interesting setting. The major valley in the center of it is one of the most productive agricultural regions in the entire world and provides 90% of certain fruits and vegetables and nuts to the US and a huge proportion of international produce and nuts as well. A key distinction in California, it has the most variable hydrology in the country by far, which means some years it rains, some years it doesn't. It doesn't rain and snow in the part of the state where agriculture and population are the greatest. It doesn't do it in the time of year when water is most used. And so as a result, we actually have a very elaborate system of public works, of storage and conveyance that really makes modern California possible. The key challenge to California under climate change is, of course, that because we have a need for storage and conveyance to last us many years and across seasons, despite the fact that we have groundwater basins and we have reservoirs, fully 1/3 of our storage in an average year is in our snowpack. And that is exactly what we're going to lose under climate change with even a few degrees temperature rise. And so there is what I always call a freight train of pain coming down the track in the coming decades to California that will make the conflicts we have today seem like a party or a picnic. And so there's no time to waste, particularly since over half of our population lives in Southern California, which is 60% dependent on imported sources of water, either from the Colorado River in the south or the Sierras in the north. Next slide, please. So folks in Southern California in particular are moving very quickly, and some of it has evolved over decades, and a lot has accelerated rapidly just in the last few years since our historic drought that we had in the middle of the last decade. And there are multiple agencies with enormous plans, with the city of LA proposing to go to 100% recycling by 2035, reducing its dependence on imported water by 70% by that time. Metropolitan Water District, which covers all of Southern California, proposing an 150,000 acre feet, I'm sorry, I didn't do the translation, recycling project, which will be the largest in the world. Orange County already is the largest at the moment for groundwater augmentation, and Los Angeles County proposing a very audacious stormwater capture project that is geared around multiple benefits of water, preventing flooding, providing water supply by getting it into the groundwater basins, cleaning up water that flows off the streets and into surface waters, and urban greening in a very park poor area. And there's more in Southern California, but let's move to the next slide. So in the state of California, we tend to have very tough regulations on water quality, less so on water supply. That's pretty much left up to cities and held fairly loosely. And during the drought, we did a number of things. We did a lot of things, but I'll mention a few. One was to put out more than $1.5 billion in grants and loans to try and take some of these recycled water projects off the drawing boards and get them into construction. And many, many of them are now in construction as part of the planning I talked about. We also set new statewide, this is the strategic regulation example, we set statewide permitting standards for all kinds of recycled water use, both non-potable uses, but also indirect and direct potable on the way in 2023. And those regulations at a statewide level, as opposed to it being dependent on local permitting, unleash the ability of those communities to really plan for a massive expansion of their recycled water use. In the stormwater setting, and I loved seeing some of the earlier presentations that gave a visual of that, in LA, we took a permit that was just about water quality in the quality of the water that ran off the land, and we gave more time. This was very controversial. We gave more time to the community if they were going to do a multi-benefit approach of flood control, water supply augmentation, water quality, and urban greening, because we wanted to be a part of that very challenging local effort. And it played some part, at least, in the area coming together and passing a measure to spend $300 million a year on these incredible projects. So you will see the LA area transform over the course of the next decade. And we were happy to be a part of that, as opposed to just sticking to our role. Next slide. Now moving quickly through the other examples. In Melbourne and Victoria, you have a similar climate and a similar setting and a similar challenge under climate change, except they did face their worst drought in modern history, their millennial drought in the mid-90s to the mid-2000s. They got through it with some incredible work on water savings and recycling. Expensive desalination plants were built, and incredible work on stormwater capture and urban greening. Next slide, please. You see a picture. This is a big part of Melbourne's sense of self, and they did an incredible job, and they are facing some of the same challenges under climate change. Next slide, please. And what they did, there the state government does direct policy on water supply, and they set targets for recycling and conservation and a host of other things. They also gave assistance, but there they have a policy ban on the use of recycled water for potable purposes, even indirect potable. And so as a result, Melbourne may have spent a lot more money on the non-potable system than they could have by doing it in an indirect potable way. And I just read in the last week or so, an advisory committee to the state has suggested moving in that direction. Next slide, please. Denver, Colorado, similar issues. It falls in the western and the more arid part of the US, dependent also on the Colorado and facing those same challenges. Next slide, please. And there we had a more specific issue where the state sets water quality limits that definitely also limited the use for any kind of indirect potable reuse. Here in Colorado, the Denver Water wanted to do a new campus doing state-of-the-art sustainability, and they wanted just to use treated wastewater for toilet flushing, but it wasn't allowed by state law. To resolve this issue actually required legislation to require that the agency work on standards for this. The agency only had about 2 people in that arena, and Denver Water helped pay for the staff to make it happen. They got it done, but it was challenging. The water supply arena and the water quality arena are not in the same agency, so they didn't own the combination of those 2 issues. Next slide, please.
Please come soon to conclusion.
Yes.
Thank you.
Thank you, just about. And now, next slide, please. Next slide, please. And now ECOHYDROLOGY, which is a closing example, which is a very exciting one, a very complex one I recommend reading about. It is an amazing arena where you have Durban at the center and you have a municipality which is much larger, which is responsible for services. You have a national priority on the human right to water, but you also have a priority on having things pay for themselves, the 2 of those seemingly in conflict. But it is a city of contrast. You can see the thriving city of Durban, port city. Next slide, please. But then you move quickly to informal settlements with people moving in rapidly, very hard to get services there. And then very quickly, you also move to rural areas, very hilly and hard to extend services. Next slide, please. And what they did in a very creative approach was to figure out how to provide both water and sanitation services across this very challenging arena, including free basic services in terms of water, using different tiers of service and engaging communities in the provision. Next slide, please. And in perhaps the most interesting part, in the sanitation side, a whole series of different tiers of services, including job creation and community ownership, and also the provision of free emptying and other services from the state. And they did such a good job of this creative approach that now they have national support, and the nation is both promoting this across the country and across the world. Next slide, please. And in closing, again, I won't go through all of these, but there's a choice to be made by the nation and the state about how to help. And the key thing is to really understand the mindset and the challenges holistically faced by those megacities and figure out how to bring tools to bear in partnership, in addition to the regulatory role, which is also very important. But really understanding the challenges faced at the local level are very important, and allowing for innovation and creativity. Next slide. And then finally, including people in the process, using a whole suite of tools versus just bequeathing rules, and to keep up with innovation. And then finally, last slide. To meet the climate change and the human right to water challenge, we really, really need to figure out how to reach for this all in it together approach, or we simply won't get there. And it's about attitude and choice and strategic thinking and strategic use of tools. Last slide, thank you very much.
Merci beaucoup, Felicia, pour cette présentation.
Thank you very much, Felicia, for this presentation. I'm sorry because I had to stop all of you. We needed to be short.
Mathilde, you're presenting a more specific case which has a strong technological challenge, diverting toilet. It's a big challenge. You have the floor.
Thank you very much for the introduction. I will indeed talk about the source separation system and the life cycle assessment, so the evaluation of this source separation scenario on a case study on a new district in Bordeaux in France. So next slide, please. So why source separation? In fact, it's the new challenge in wastewater and in sanitation systems is to move forwards to resource recovery and not only end of pipe system and waste treatments. Because in the wastewater you have resources that you can collect and reuse in our world. You have nutrients, nitrogen and phosphorus that can be used for agriculture and that we need for agriculture, organic matter and also water. And these different elements are not divided equally into different streams in wastewater. Because wastewater is can be divided in feces, urine, and grey water. It's all the water that we produce in households. And you can see on the different diagram that, for instance, feces contains most part of the organic matter, but for a flow of a volume of water very low. So it's a very highly concentrated streams in organic matter. The same for urine. Urine contains most parts of the nutrients and especially nitrogen for a very low volume. And the rest of the water, the grey water, so the water which is not coming from toilets, contains, well, most part of the water. And for this time, it's quite diluted in organic matter, nitrogen, and phosphorus. So the idea is to say, okay, if we separate the streams in the households and in the building, we can be able to implement processes which will work more easily and more efficiently. to recover the resources. So two main source separation system have arisen: the urine separation and the black water separation. So first, urine separation will be performed with urine diverting toilets or urinoles. You have photos of what can be urine diverting toilets. And as it's a low volume, you can transport it by trucks until where you want to treat it. And the main objective for urine separation is to reuse the nutrients in agriculture. And the black water separation so it's the water coming from toilets. And in this case, most of the time in the pilot project, the black water, is collected by vacuum toilets. So it's toilets in the train, or you can see it on planes, where the flush volume is quite low. It's only 1.5 liters per flush. Again, 3 to 6 liters in conventional toilets. So the black water will be concentrated, and you have to transport it by vacuum sewer. And most of the time, when you go to black water separation, you can go to recovery of energy coming from the organic matter. And at the end, the remaining wastewater can be reused also in agriculture to reuse the nutrients. Next slide, please. But source separation implies a lot of change in the whole sanitation system, because you have to change the toilets in the household, you have to change the collection system. So you go to trucks, you go to pipes, or you go to vacuum sewer. And you have also to change treatments, and it's not conventional treatment. You have to reuse, you have to recover resources. So you have to have also the actors ready to use your product. So it's really difficult to choose which system to implement in the different scenario and in the different city, district, and so on. So we decided to create a tool to help us to evaluate the scenario beforehand. And we wanted to have a scenario to help to the evaluation of several types of source separation, several treatments, and to take into account the whole change of sanitation system from the production of wastewater to the recovery and reuse of the materials. And most of the time, source separation systems are implemented at the district scale, meaning that a new district is constructed and we are thinking about a way to do it better. But it's not the same if we implement it and deployed source separation system in very high densely populated area or in pavilions, for instance. So we have to take into account the urbanism. So the tools that we developed need to be focused on district scale with different urbanism types. So it's what we have created. Next slide, please. It's a tool, a modeling tool with 3 different blocks. The first one is the modeling of what happened in the district with the definition of how much water is produced, the transport design, the transport treatments in the decentralized facility, and it's linked to the modeling of the centralized treatment plant, because in most of the time you will have an hybrid system between decentralized treatments and centralized and the current facility. So in our model, we have a much more defined model to have the effect on source separation on the current treatment plant. And at the end, the results of both blocks will be linked, and it will be able to generate an inventory used for life cycle assessment. And once again, it's coming from wastewater collection to the recovery and reuse of the material. So it's really the whole sanitation system. Next slide, please. And this tool was used first for theoretical districts, meaning that we wanted to have the information and have the effect of what happens between source separation system and urbanism. And now we tried to use it for real case study. And we took the Belvedere district. So it's a district in Bordeaux, in southwest of France, near the Garonne River. And this Belvedere district is under construction. And at the end, it will be around 9 hectares of district with a mix between households, hotels, offices, business, and shops. And at the end, normally we will have around 2,000 inhabitants and 4,000 employees working in this district. Next slide, please. So we wanted to say, okay, what could be the best solution to resource recovery from wastewater? So we tried with the tool 3 source separation scenarios. The first one is urine separation, where the urine will be collected from the buildings and transported by trucks until the centralized facility, which is nearby the district. The rest, the remaining wastewater, the gray and brown water, will be sent to the treatment plant also. And I will show you afterwards which treatment will be implemented for the urine. The two other scenarios, are with black water separation. So the black water will be treated in both scenarios in the district with decentralized treatments. And as I said before, with vacuum toilets and vacuum sewer, and the treatment line to recover energy with anaerobic digestion, recover phosphorus with provide precipitation, and recover nitrogen with an innovative process called transmembrane chemosorption, but it's a recovery of nitrogen. And the gray water in the first scenario is sent to the wastewater treatment plant. So this scenario is like a semi-decentralized treatment. And finally, the last scenario is a black water, gray water, is a totally decentralized treatment. The same processes for black water treatment, but for gray water, we introduce here a decentralized treatment with the membrane technology to treat the water. And this membrane technology allows to have high quality in the effluent, in the outputs, and we can be able to reuse it in the district if needed. Next slide, please. So this the 3 scenario of source separation scenario will be compared to a conventional management of the wastewater, which is a centralized treatment in the wastewater treatment plant. And in the case of Bordeaux, the treatment plant treats the organic matter and partly the nitrogen. And there is a specificity. It's a large unit. So there is an anaerobic digestion of the sludge to produce already energy in the treatment plant. And that's the goal of the study, was to say, okay, we go to source separation scenario to recover resources. We wanted also to compare what can be the best that we can do in the centralized facility in order to avoid to be the best in source separation scenario and not the best in the centralized facility. So we will have 2 references. The first one, it's the current situation in the treatment plant. And the second one will be an advanced treatment plant where nitrogen will be also recovered. So you can see on the diagram, the blue process, it will be a recovery of nitrogen in the sludge line. And in the yellow box, you can see also the urine treatment. It will be a process dedicated for urine to recover phosphorus and nitrogen. Sorry. And finally, so the next slide, please. The tool is able to assess the environmental impact of our solutions, and we perform life cycle assessment. And life cycle assessment is a multi-criteria analysis, so we have several indicators on the impact of our systems. But for today, as I don't have many times, I will just focus on 2 criteria: the global warming potential, so climate change impact, and the energy consumption.
Merci de venir à la conclusion.
Okay.
If you can come to a conclusion, please.
So yeah, we go to the next one. So the global warming potential, you can see the first reference scenario. So the main, sorry, I'm disturbed. So the reference scenario you can see that there is a large amount of the climate change impact which is coming from direct emission. It's the emission of nitrogen into air, in fact. And with the all source separation scenario, you can reduce this amount of direct emission. So it's a good point. And in the meantime, sorry, just a few words before. It's the other benefits of source separation system is to recover nitrogen and reuse it as fertilizer, and you avoid the production of fertilizer. But if we go to cumulative energy demand, so it's a primary energy demand, you can see that the scenario with black water separation will consume a large more energy than the other one, and it's due to a vacuum sewer and the membrane bioreactor for greywater treatment. And I will go to the conclusion, and I will try to be quick. So source separations allows to reduce significantly the impact of sanitation system on climate change, thanks to the nitrogen recovery. And it's really the main point. If we go only to organic matter recovery and energy recovery, or just phosphorus recovery, the climate change impact will not be decreased. We have to go to nitrogen recovery to decrease the emission into air and to avoid the production of fertilizer. And energy consumption also is quite difficult to assess, especially in France, because we have nuclear energy. So there is not a huge importance of electricity demand in climate change impacts. But the two scenarios with black water separation will increase the energy demand and will increase the cost of this system, and obviously the acceptability of it. And I will thank you.
Many thanks. Merci beaucoup, Mathilde.
Thank you very much, Mathilde.
Question and answer item, or maybe in the chat as you want. So I will begin the discussion with one question for each one of you, and many thanks for your very interesting presentation. Maybe we begin in the order to Carola. And you stress the importance of historical perspective of resilient development in big port cities. There are many opportunities for reallocating old port infrastructure that new shipping don't need. Could you give some good example or maybe bad example from your methodological point of view? Or in the cases you studied in London, Hamburg, and Rotterdam, on the way these old infrastructure have been used?
Thanks a lot for that question. First of all, I think it's important to point out that we are looking at historical past dependencies and the way in which historically decisions have been made. And I think what we're finding is that often the choices towards waterfront regeneration are in line with earlier decision making. So if in London a port moves out and leaves shipping activities behind, you can also see in the docklands, for example, that it's really urban reclamation. It's just a new part of the city to be extended into. In the case of Hamburg, you have a much more integrated approach to a multifunctional district that is being implemented in this district, and that has also become a UNESCO World Heritage Site. What's interesting in Rotterdam, for example, is the way that makers districts have moved into historical water or port facilities, so that you're trying to come up with new ways of engaging even the maritime business through 3D printing, through a maritime university, to keep the connection to the port going. And in terms of a recommendation, because the waterfront regenerations that we have so far been dealing with are perhaps the easiest ones, because we're dealing with pre-19th century historic ports with a few interesting warehouses, cranes, and buildings of relatively small scale. There we can still hope that they are integrated in a networked way and not just as unique elements, so that we show how maritime trade served from the water to the hinterland. But the heritage sites that are now coming up, which are, for example, the former petroleum sites, with extensively polluted soils at much larger scale, perhaps more difficult to reach also, those will be a whole different level of challenges. And once the cities understand, and that's the hope what we have with this methodology, what the path dependencies are that they've been dealing with, then maybe they can come up with new ways to deal with the, the future challenges, like the ones of the big petroleum sites.
Many, many thanks. So now to Felicia. You showed how incentivized collaboration and inclusive co-construction bring better results than top-down regulations. Your lesson learned you presented at the end are completely in accordance with the practices we tried to impulse in the Water Governance Initiative at the OECD. And we developed principal indicators and auto-assessment tools, and the cases you present are completely in the same spirit, I think. In the cases you presented, the questions of the architecture of how the nation of the state interacts with its cities is particularly interesting. This question of scales. Do you have some lesson learned, a common theme that you can bring from this experience? And I have another question, which is rather different, but very interesting. I think that you speak about climate change and you speak about human right to water. And we all consider that there is a link between them. They have to deal together. And so if you have some comments on that. Thank you.
Oh, no, thank you for that. I think the common theme to both of them in the context of how we looked at it is this question of attitude. It seems that, regardless of the governmental structure, government officials are not just automatons implementing a structure. They're human beings that can bring their whole selves to the conversation. And it is very easy, regardless of what your structure is, to just do your job, to stick to your widgets, whether it's as a water quality regulator, not thinking about the other needs or the cost of dealing with water across flood control, water supply, water quality, or even urban greening as somebody else's problem. But if you take an attitude of, here's a place with people that we both serve, how can we help you if you're trying to do a good thing? There's a big role for regulation when folks aren't trying to do the right thing, or they need a kick in the pants, as we say, or you need to have a level playing field. There's definitely an important role for that. But there are a lot of cases where understanding the needs of cities, and I come out of local government, so I feel strongly about this, and how complex it is, can make a world of difference in terms of thinking about, well, how do I use the tools I have to make it easier for them? In one of our cases, it took legislative intervention because people were in a different program. In California, they had moved the drinking water and recycled water problem into the same unit in 2014 precisely to deal with this kind of an issue. And it helped us be able to own the whole problem that these communities were going to face. The climate change, and I'm going to move quickly since I took so much time, the climate change and human right to water challenges are also about attitude, in that both of them are existential threats of different kinds to people with real impacts on people. And as opposed to staying in our little silos of the roles we've been assigned or the authorities that we think we just need to implement, which is a very safe way to go, we really need to step back and say, well, how can we help? And the ECOHYDROLOGY example, which I really encourage people to read about and we'll be able to talk about in more detail, which involves some of the elements that Matilda was talking about just then in different kinds of management, was a moment where the national government let the locality experiment despite the sort of the impossibility of meeting both needs quickly and figure out how to prioritize getting basic sanitation and water to people faster while generating engagement and jobs and resources. And it was, it's a work in progress, but it's become a world leader in the fecal sludge movement and in other ways where the nation could have just been a barrier and it said, let them innovate, and now is promoting that innovation. Again, attitude, not just law or regulation or policy.
Many, many thanks. It's very, very interesting. Mathilde, je viens à vous. J'ai deux questions.
A question for Mathilde. I have one question from the chat and a personal question. The question from the chat is very technical. When you carried out your comparative analysis, what was the time sequence you worked on, and did climate variations have any impact on your analysis? And my question would be more of a cultural question. You mentioned the technical issue of efficiency of the system. We know that separating urine, if public stakeholders were to carry this out, that would require quite a cultural adaptation. I was wondering whether you knew what the level of mindset maturity is in terms of acceptance of these innovations.
About the input time series. In fact, we only focus on wastewater and not on rainwater. So there were only steady state simulation and not dynamic simulation. So it's only the average wastewater coming from the district and from the Bordeaux city. So there is no dynamic input and time series that we considered. And for the second question, maybe I will respond in French because it's much more complicated for me in English, this part. Mais dans cette étude qu'on a menée...
So in this study, in the assessment part, we had a very close look at technical indicators, but not so much at acceptance criteria. But once we moved on to the design phase, we worked with a Parisian laboratory that works on and focuses on ownership of solutions by sanitation players. So not so much the end user, but the intermediary stakeholders. So in this case, wastewater companies. So separation at source, only 5 years ago, was still an unfamiliar notion for the stakeholders we were talking about. So it took time to discover and explain these notions, these concepts. Now we're in a second phase where this is a concept that is better understood. And there's a project in Paris where there will be a separation of waste channels, which is a big step forward. And in terms of end users, again, separation at source is something that was not well known. And when we carried out studies, surveys, this is a solution that they didn't necessarily know of. There was a, well, why not attitude towards it. And the main issue is reliability of toilets, because that is, of course, the area where the location where for the end user there's an impact. So they basically want to make sure that toilets will work. But generally speaking, the idea that there would be separation, etc., is not an issue. The real question is in terms of micropollutants, pharmaceutical residues in urine, and this is an issue that has had more and more media coverage, and so this is a concern they identified.
To each of you, and so My question is very simple. We are speaking about a new culture for water, and a new cultural approach. In a few words, what are the main streams of the today changes in this culture of water? Maybe first we could go to, in the order, to Carola. What is very new now?
Well, I think the main message is we need to think water as a system. So from rainwater to shipping water, it's just the same water and it needs to be considered together. We need to bring together all the stakeholders in order to create what I would call water awareness 2.0. So from the Netherlands, where they created first water institutions some 800 years ago, we have to go back to bringing in everyone, every single citizen into being aware how water is distributed, cleaned, etc., so that everybody can participate, which is currently not the case if we have a purely public system. And third, I think we have to place ourselves in time and not only think about very short-term solutions, but really think about the longue durée. Where do we come from? Why did we make the decisions we made? And what do these decisions, if we extrapolate them in the long future, mean for generations to come?
Felicia, what could you add?
That was very good. I would just add that we all in this time of change and scarcity and need to think about what a friend of mine calls more pop for drop in water, of not as poetic as what Carola just said, but that water for all its needs, we need to think of the most efficient and effective way to use and reuse it. And we need to have an attitude of we're all in this together and play our roles, to be sure, but also not play our roles in isolation from each other, and figure out how to use all of our tools towards the end of making our cities and our people more sustainable and safe and resilient.
Et Mathilde?
And now, as I am the last one, it will be very difficult to add something. But I agree with both of you, Felicia and Carola. The thing is that it's easy for us to stay focused on one thing and one role. Wastewater, rainwater, potable water, and going farther, urbanism and so on. And everything are linked. And it's complicated to take into account all these things. And so it's disturbing for us. But it's really the main challenge, I think, here, to try to talk to each other and go further our main challenge and go and try to see the other one challenge, because sometimes there is solutions for one which could be also for the other one. So I think multifunctionality also, it's a really important thing. Try to respond to several question and answer with one solution. Water can be used and wastewater treatment can be used just for treatment, but it can be also used to bring water in the city and to, we have seen blue and green networks. So it's also a response. So thinking more largely, I would say.
Many, many thanks to everybody. You were wonderful. And now I think that our time is over. Thank you very much for your work. And see you later.
Thank you.
Thank you very much.
My thanks as well.
Attendez, je les ai pas, je les ai.
Nous voici arrivés à la fin de nos sessions scientifiques et techniques avant la séance de clôture.
We've reached the end of the technical and scientific sessions. Before the closure, I would like to invite you to hear the youth declaration. Benjamin Srelinski and Renan Shah, you have the floor for 15 minutes.
Thank you. I am Renan, and I, along with Benjamin, will be presenting the Youth Declaration on Water, Megacities and Global Change. We, the Youth Steering Committee of Omega 2021, are young people working on water from across the world. The members of the YSC, along with youth organizations and networks working on the issues of water, megacities, and climate crisis, got together to discuss the water challenges related to megacities and global change. Each one brought their own knowledge and experiences to share in the firm belief that youth can be the drivers addressing such challenges in the world. This declaration reflects our views, which was also highlighted and discussed during our pre-conference event, the Youth Online Panel on December 7th, 2020, for the Omega 2021 conference. This document presents ideas, experiences, suggestions for actions. Next slide, please. Water issues need to be seen from a systemic point of view and with the understanding of systems level changes. It is critical to achieving the interlinked SDGs and debunking the traditional concept of water sector as merely being referring to utilities. The unprecedented challenge of COVID-19 has also emphasized the vital importance of water, sanitation, and hygiene services for everyone, everywhere. The current younger generation will bear the brunt of future problems, if not already, in our megacities. So young people need to be a part of decision making, policy making and analysis, investment planning and implementation of decisions that will determine the future world. Young people are aware of the issues that affect the megacities, and we believe that they are capable of catalyzing systems level change. Hence, the viewpoint of young people, as well as other demographics such as women, elderly, people with disabilities, LGBTQ plus persons, and indigenous peoples should be acknowledged, respected, and included when considering problems and solutions. Advocacy for resolving water and climate issues must involve all parts of the society, including the public and private sector, media, and civil society. Governance systems and policy frameworks differ greatly between cities, but such differences should not hinder meaningful youth engagement. This document consists of the challenges faced by megacities in the context of water and climate, identified by the consulted youth organizations. The first part covers challenges regarding the water and climate issues in megacities, and challenges regarding meaningful and also challenges regarding meaningful youth engagement. This is followed by solutions for the challenges identified, proposed by the youth organizations in the similar order. The solutions we have tried our best to provide and match a one-to-one comparison. Next slide, please. The challenges faced by megacities with respect to water and climate are: in some megacities, the right to access to water, including safe and reliable water supply, sanitation and hygiene, is still not recognized and or are not implemented, and thus communities struggle to acquire even a basic amount of water, which affects the quality of life. In many places, communities do not have access to sewage treatment network, thus elevating the risk of diseases. Many of the proposed and implemented solutions are short-term, with no regard to the local ecology, geography, the social and political economy of the region. This is also because of lack of strong institutional structures, systemic, integrated thinking in policy and planning, not only between disciplines, but also between various actors. The problems across the world are comparable, but often there is no transfer of knowledge from one to the other. Most of the solutions are hard and technology-centric. Within the households, women, who are the main people responsible for water, are in all aspects, such as collection, storing, and rationing for use, are almost always neglected in the water sector, especially in water science, technology, and policy making. Global convenings have limited accessibility due to linguistic barriers, attendance costs, and lack of information sharing. In the face of increasing water crisis, issues of political stability among nation states in a region also leads to conflicts regarding availability and control over resources. Planning for the development of water and sanitation in megacities does not take migration into consideration. The imbalance between available and recovered water in the basins of megacities have caused water stress in such basins. Moving on to the challenges which we feel, next slide please, regarding meaningful youth engagement. We feel that there is a vast lack of space. There are few or no mechanisms for youth to voice their concerns to issues like access to information, data, training programs, as well as job opportunities in research as well as practice. Outcomes of consulting youth and other civil society are not incorporated meaningfully into policies and other programs. Global conventions and conferences often do not involve young people both as speakers or participants. There are insufficient professional development schemes and knowledge exchange platforms for young water specialists. Young people face barriers in presenting their research and exchanging ideas with senior professionals. Young people are also unable to access financing to develop the research and prototypes. There are very few young people who express the interest to be a part of the water sector and or study water. Young water researchers with innovative ideas for applicable technical solutions to solve local problems cannot find support in terms of implementation pathways. Lastly, the potential abilities that may contribute to solve water issues such as communication, digitalization, and knowledge exchange between professionals at an early career stage have been underestimated by current decision makers in several regions of the globe. I pass my mic to Benjamin to discuss the solutions. Thank you.
Thank you, Renan. Next slide. Yeah, next slide. So firstly, in terms of solutions for megacities with respect to water and climate issues, we would firstly like to encourage decision makers to recognize and implement the right to access to safe and reliable water for all. Secondly, to prioritize ensuring sanitation and the employment of sewage treatment technologies. Thirdly, to adopt a holistic approach to understand the interlinkages between water, climate change, and livelihoods of residents of the cities. Fourth, to leverage potential of international associations and networks to address issues related to gaps of knowledge and lack of knowledge and technology transfer. Fifth, to implement inclusive programs and policies in decision-making, research, management, and technical positions in the water sector to make sure that systemic approach is accounted for and implemented solutions meet the needs of the specific local ecology. Sixth, to provide interpretation and subsidized attendance at global convenings, especially for marginalized communities and those who have limited opportunities. And seventh, to work towards creating better systems at transboundary levels. Next slide, please. In terms of solutions for inclusion of youth in the water sector in megacities and beyond, firstly, we suggest to create channels for youth to voice their concerns and suggestions to the decision makers. And these need to be institutionally implemented and well-resourced. Second, to incorporate accountability measures in the policy design process to make sure that whatever is put on the table will be brought to life. Third, to include young professionals and youth organizations in the global convenings. Fourth, to improve the availability of short training, degrees, programs, seminars, mentorship, and other technical and theoretical programs that will help young people enter the water sector. Fifth, to establish youth research groups. Sixth, to provide funding for youth initiatives solving the challenges of megacities. Seventh, to cover water issues in educational curricula so that all young people get to understand the importance of water and climate change in megacities. And lastly, to convene youth for community or city level challenges and support the outcomes of these sessions to ensure development and implementation of locally attuned and community specific solutions. Next slide, please. In conclusion, we call all of the present decision makers and other stakeholders to acknowledge the youth perspectives on the issues of water, megacities, and global change, to open up spaces and opportunities to include the youth and the marginalized communities. Third, to take a holistic approach to understand the interlinkages between water, climate, and livelihoods. And lastly, to keep in mind the local ecology, geography, and social and political economy of the region for any policies and solutions. We hope that all of you present today will take those suggestions, and we are looking forward to seeing how they'll be brought into life, including when we convene next year for the Omega 2021. Thank you.
La session de clôture va commencer immédiatement.
The closing session will be starting now. It will be headed by the chair of the steering committee, Omega, Mr. Jean-Claude Dutch. You have the floor, sir. Hello, thank you for giving me the floor. I am Jean-Claude Dutch. I'm a member of the ARSO-IDF Association, and I'm speaking here as the chair of the steering committee of this conference and pre-conference. We are at the closing session, and for this closing session, we've called upon a certain number of persons so that they can start take stock of the conference and how to make a bridge between the conference that we, I hope, have in December of 2021 as a physical meeting. Now, I personally appreciated a great deal all the contributions of this pre-conference, and there were very interesting questions, discussions, despite the new system that we have applied of working in a virtual meeting. I believe that the communications have really emphasized a certain number of points that are very important indeed with regard to the subject that we are dealing with, water, megacities, and climate change. It has shown the importance of the coming together of a certain number of actors in water management, that is the civil society and its political representatives, the researchers, the scientists and technicians of the different service companies working in the field of water, the structure of which is also based on this structure. It has also shown that the solutions to the problems that arise can only be multidisciplinary, otherwise they will be missing out on their objective. Something else that I wish to emphasize is the fact that the mega cities not only bring problems but also solutions through all the stakeholders that exist within them and that are working in the field of water. And finally, I'd like to say that as the chair of the steering committee, this is an important step. The pre-conference step is an important one. It has been over 2 years that we have been working on this aspect, and we were not expecting the pre-conference. We've made it, and we hope that a conference will be held at the end of 2021. Now, quite obviously, the steering committee is not the only one in charge of this pre-conference, and the whole of the committee will join me in thanking, in particular, the sponsors that have allowed us to finance this pre-conference, the speakers, the moderators who have given to this pre-conference a very high quality. And I would especially like to thank the teams of UNESCO, ARSO, IDF, and SIAP, teams that have been working very hard to ensure the logistics of this pre-conference, and thanks to whom it has taken place without any problem. And in fact, it's been perfect. May I now give the floor to our first speaker of the closing session, Mr. Abu Amani, who is the Interim Director of Water Sciences and also Interim Secretary General of the IHP. Mr. Abu Amani, you have the floor.
Thank you, Jean-Claude, and thank you to all. After these 5 days of discussion, it's time to take stock, and also it's time to thank all those who have participated, and it's also a time to reflect on the next steps for the future. If we start by taking stock, if we look at participation in this pre-conference, we can indeed celebrate the outcome. Over 1,000 people have connected each day to listen to the 45 presentations that took place on a number of diverse topics, whether it be holistic water management, business continuity, resilience to disaster. All these issues cover the various aspects of water in urban areas. And so the high participation rate indicates the relevance of this pre-conference and of the upcoming conference of 2021. How about the next steps, the future? As you know,
l'année prochaine, au moins 150 articles.
We have received already a number of scientific papers, and another 150 scientific papers will be discussed next year. There will also be technical visits, poster events, and there'll be a cultural exhibition. So all that will contribute to the wealth of knowledge. And then there will be the Mayor's Congress and the Megacity Water and Climate Change Forum. So all these events will congregate at the 2021 conference that we hope will take place face to face. As I said during the opening session, in the name of the Deputy Director General, it is a great pleasure for UNESCO to host this meeting. Our role is to enable discussions between science and politics, between science and decision making. What is also important for the future is to think about the impacts of the pandemic on water management in megacities. And as we launched the call for contributions early 2020, we didn't have this element in mind. It was before the pandemic. So this will be added to the call for contributions early next year. So to integrate the issue of the pandemic and its impact on water management. And this will add a further topic, a further approach to the topics covered during the conference.
Many stakeholders. So I would like sincerely to thank our key partners, committed partners, SIAP, the Greater Paris Metropolis, and ARSO, who are also our co-organizers, as well as our DIAP sponsors, Eau de Paris and Agence de l'eau Seine-Normandie. I would like also to thank our chairperson of the Intergovernmental Hydrological Program, Professor Fadi Komer, who was able to participate in this important pre-conference as a moderator. And I would like really to thank him for his leadership and all the support he's providing to the program. I would like also further to thank all the moderators. I think there are more than around 10 moderators who helped to guide the discussion during these 5 days. My thanks go to our youth steering committee for the support, and my colleague at the Division of Water Sciences, especially Alexandros Makargakis and Maud Bertolot, who were at the heart of this week. I think they were the one who led all these big events from the UNESCO side. My thanks also to the technical service provider, because without technical support, the interpretation, you cannot have such kind of event. Our special thanks go to our program committee members, especially the two co-chairs, Dr. Blanca Jimenez Cisneros and Dr. Jean-Marie Michel. I would like also to appreciate and to thank Her Excellency, the Ambassador and Permanent Delegate of France to UNESCO, Madame Véronique Roger-Lacan, for her support and particularly for her closing message for this pre-conference. Last but not least, we are very grateful to all of you, the participants, because without participants, you cannot have the conference. And your active participation made this pre-conference a success. And we are looking forward to welcome you next year in December 2021 in Paris at UNESCO headquarters for finally the Omega 2021. Thank you for the kind attention. Back to you, Jean-Claude.
Oui, merci Abou pour ces.
Thank you, Abu Amani, for these words of thanks. I would like to echo your thanks to the program committee who have been instrumental in setting up this pre-conference and have been extremely helpful in the organization of the event. I would now like to give the floor to the two co-chairpersons of the program committee, Mrs. Blanca Jimenez Cisneros, Director General of CONAGUA, Mexico, a federal authority in charge of water management in Mexico, and Jean-Marie Michel, professor at the University of Paris-Sorbonne, and co-director of the Seine Basin Authority. The Seine being, of course, the river that flows in Paris. And the organization he chairs works on water analysis of the Seine and the Seine's catchment area. Blanca and Jean-Marie, you have the floor. Blanca.
Bonjour à tout le monde. Merci beaucoup.
Good afternoon to all of you. It's a pleasure. Thank you very much.
And Secretary of the Intergovernmental Hydrological Program of UNESCO, Excellencies, Mrs. Véronique Roger-Lacan, Permanent Delegate of France to UNESCO, Professor Jean-Marie Michel, co-chair of the Program Committee and the members of the International Steering Committee of the O2020 conference. First of all, I would like to congratulate all the organizers for the effort it took to adapt such a complex event into a successful program and provide such nice results. Megacities face two major challenges that undermine water security of their inhabitants: population growth and the access to basic sanitation. But most of all, and in this new context, we have faced the COVID pandemic. That has put us an additional pressure. And if I may add, in the context of Mexico, we have faced in this year the COVID, the economic problem related to it, the water challenges, an earthquake, and very heavy floods. And what it left us to all of us and listening to what Mr. Amani was saying. After all these challenges, we have learned that we can deal with many, many challenges, that we have learned to live in a different way, that even the fact that we cannot travel and to meet with each other, we can establish different links and continue working as a group. I think that's the most important thing that led me this period and this conference, because this conference shows that we still can collaborate. Urban population need and demand water services in adequate quantity and quality. Given now the recent news that we heard from the United States, that water is now a part of the, oh, I forgot the la bourse in French. Also is making, how do you say in English? Well, it's now in Wall Street. So that makes us as well think in a different manner of what we can do in megacities concerning water, because this will impact mostly megacities. At the same time, there are different types of contamination problems, those for developing countries, megacities, but as well those for developed country cities. This is teaching us that we still need to protect water and to try and to use it in a wisely manner, giving it not only a price to water, but as well a proper value to water. How to incorporate all these elements in the new context, in this new context where we have, in addition, natural disasters. The only way to do it is through collaboration, through linking and learning from each other, seeing what the future can bring us. I agree that climate change is a factor, but mostly, and reading what IPCC is telling us, for water, climate change is only a variable. The most important thing is the way in which we are relating to water, the way in which we are developing the world, and we need to find a better way to manage this precious water. It is imperative that those of us who are decision makers adopt innovative technological measures and develop efficient urban planning tools, which is a challenge because cities have too many problems and water is only an additional one. Since hydrometeorological disasters are more frequent, we will need to have more integrated water resources institutions. The most I see the difference between cities and countries in the way they manage the water, I think is very important to have it in the way we have it here in Mexico, where it is the same people who is dealing with all the aspects of water. This can deal to a truly integrated water resources management. And also that this is a way to work in a more holistic way that will improve water sanitation. But at the same time, the role that the social media is playing, it's also an emerging issue concerning the water. More and more people can communicate among them and put or create, if I may say, virtual problems that are also important to address and sometimes deviate the attention that we need to put in many cases to those that still do not have water in megacities from the developing world. And that's the main role we are playing here in Mexico, following the instructions of our presidents that have put the poor first, and it's our also very similar to the 2030 SDG goals. We need to leave no one behind and to leave no one out concerning the water. We are working very hard to achieve this goal. I hope that we can continue working and sharing experience to enrich our work, and I also wish to be able to greet you at the International Omega Conference in 2021, where we can still continue collaborating. Thank you very much.
Merci, Blanca.
Thank you very much, Blanca. My turn. So on behalf of the program committee, I would like to, of course, thank all the people who have participated in this pre-conference Omega 2021 Water, Megacities and Global Change. The presentations were of great quality. The moderation was perfect. And for those who haven't done so, I'd invite you to consult the written communications which are available on the website and which are equally excellent. I cannot resist the pleasure of thanking particularly the members of the organization committee who have done amazing work, affected, of course, by the deadlines and numerous uncertainties due to the COVID-19 pandemic. And despite this, the committee has succeeded in the tour de force in setting up this pre-conference under conditions that were excellent, and I'd like to congratulate in particular the organization, technical organization that has been implemented. Right, so the decision was taken to organize the conference originally planned in 2020 in two sequences. One pre-conference that has been held now, 5 years after the first Omega 2015 conference, and the conference with everybody's presence has been put off to December 2021. This choice was important because it has actually allowed maintaining the issues that link up with the issue of water in mega cities at a position that it deserves in the world agenda, namely linked to questions of climate change. Now, the fact that this conference is divided into two has brought a certain number of elements into play, and I will try and bring some answers in the seconds that follow. First of all, the articles, the communications that were submitted for the 2020 conference that was initially planned in 2020 are de facto resubmitted for the 2021 conference, but the authors will have the possibility of modifying, if need be, the different articles, taking into account new events that will have taken place in 2020, 2021 that they will not have been able to take into account. What is more, we have decided that a call for communication, an additional call for communication, will be given, as Mr. Abu Amani has already said, in the beginning of 2021, in order to make room for new subjects, more up-to-date subjects, and this second call for contributions will be on risk management, risks being those related to drought, fires, or floods, as Blanca just mentioned, and equally risks related to the deteriorated state of our institutions, in particular linked to the epidemic that we are all going through. Now, the organization committee commits itself also for sufficient room to be made for the conferences given now during the 2021 conference. The position that these different papers will be able to have in the 2021 conference is not clear. We need to discuss that further, but very firmly we commit ourselves that a strong trace of what has been done at the 2020 conference be represented at the 2021 conference. Now, I was talking about the importance of maintaining this conference and this theme on water and megacities with its rightful place in the agenda. We are 5 years after COP21 and the Paris Agreement that was signed. Now, at the end of the 5 years, tomorrow in London, we'll be starting the Climate Ambition Summit, which marks the 5th anniversary of the Paris Agreement. Now, the organizers of Omega 2020-2021 conferences believe that it was very important to actually send a message to the Climate Ambitions Summit, given the great importance of the challenges that we are aware of and that we have discussed, climate change and water, challenges that are as serious and intense because the megacities are of big size with ever-growing population and a demand in water and risks of floods, etc., that are ever increasing. So there is a very great necessity to enhance the resilience of cities to face up to drought, floods, and access to water of all the inhabitants, and be able to treat and discuss these questions in a collective manner. So the object of this message to the Climate Ambition Summit, which aims at supporting the World Alliance of Megacities, the structure of which was sketched out in the course of the Omega 2015 conference, the alliance, the aim of which is to favor cooperation between the different stakeholders, including those involved in research, the different public policies that have a strong influence on the issues of water, and the different megacities at the world scale. The current situation of the megacities differs with different climates, different socioeconomic situations, the availability of different pressures on water resources, but also with the great variability of initiatives and solutions that are taken. Now, all these initiatives and solutions must be shared, and all the more so because the climate, economic, and social conditions are changing faster and faster, and this militates for more intense discussions. That is the object of this alliance and the object of the address that the organizers of the Omega conference propose addressing on your behalf to the Climate Ambition Summit. Now, there is a web page on the ARSO Association, which is one of the organizers of the Omega conference. Now, by a miracle, maybe the address of this website will appear on the screen. If not, I invite you to go to the ARSO website. You can have access to it to the conference, this conference, and find the text of the appeal that is being sent to the Climate Ambition Summit, and give your opinion or to sign your agreement on this text via an online survey, which is also available on the website. So thank you very much to everybody. I hope I was not too long, and we will meet in 2021. We all still have a lot of work to do on these questions on mega cities.
Thank you, Blanca and Jean-Marie. I I'm very interested in what you said about the organizing committee and the steering committee. I'd like to second your thoughts. And now I'll give the floor to Ambassador of France to UNESCO, Mrs. Véronique Roger-Lacan. Ladies and gentlemen, Excellence, this online pre-conference is a rehearsal for the water megacities and climate global change that will take place in December 2021. But it illustrates well the various issues that have been studied since the first iteration in 2015 that took place in UNESCO headquarters in Paris. None of these events would have been made possible without the support of ARSO, Île-de-France, and UNESCO, SIAP, and the Greater Paris metropolis. From the outset, we have supported the initiative bringing together practitioners, water management organizations, academics, and governments. Research and operation go hand in hand, but researchers also work with NGOs, local, regional, or national authorities. From the outset, the importance of relations between megacities and water agencies has been highlighted, and the impact of climate change had been highlighted too, but this has become obvious topics for our research today. Urbanization is growing throughout the world. Megacities are more and more numerous around the world, and therefore water resource issues are all the more important. Cities amplify water issues, but also have greater resources. Adapting to climate change in one way or another is always linked to the issue with water. The presentations during this pre-conference have illustrated the various ways of addressing these issues, whether it be technical solutions, management solutions, and the objectives of the organizers have been met, I believe, and I commend you on this. Bringing together the three key stakeholders has contributed to the success of the event, but also has contributed to supporting the actions, the joint actions of megacities, and I'd like to support UNESCO's approach for focusing on the municipal level. I'd like to thank all the organizers of the pre-conference, and I hope that UNESCO will continue supporting the development of data of this common resource for us all, water. Thank you. Thank you very much, Ambassador, for these words of conclusion. We're reaching the end of our closing session. As previous speakers have said, this is not the end. This is just one step forward towards the 2021 conference that will take place in December at the UNESCO headquarters in Paris, hopefully face-to-face. This will be not only a technical and university academia level conference, but it will bring together various stakeholders that have been mentioned. So I, on a personal note, hope to meet again with many of you in December next year. And despite these gloomy times due to the pandemic, I nevertheless wish you a very happy Christmas and New Year. So please stay a few minutes with us at the end of this conference because you will receive some logistical information about the future conference. Thank you.
Ladies and gentlemen, dear colleagues participating in the Water Megacities, a Global Change Pre-Conference. This is not the event we had planned, but events led us to use this virtual organization. It was prepared within a short notice, and that was a real challenge for organizers. We had the excellent presentation of the different speakers, but we have at the background many people we would like to greet here. We would like to thank the members of the steering committee of the pre-conference who supported moderators to prepare the sessions and for holding the session, Alexandros Makilakis from UNESCO, Cristiano Menescat, and for ARSO, Daniel Markovic, Graciela Schener-Medenes, Régis Leco, François Prévost, Jean-Claude Dutch, and myself, Bruno Dunet. We would also like to thank the people we don't see, interpreters who had a difficult job, and Raphael, who received the speakers for video and audio test. Now you're seeing the images. Sometimes the situation was tense, but there was always a good atmosphere. Thanks to our friends in Incentive Development, Julien, Laurent, for their involvement, precious involvement. We would also like to warmly thank the two young ladies with whom this conference would not have been possible, Maud Berdelot for UNESCO and Irina Sevin for ARSO. They endeavored and they spent sleepless nights for this success. It is difficult to upload people virtually. Now you can actually click the like button to express your appreciation. On behalf of the members of the steering committee, I would like to thank you for participation. We'll meet again in 1 year's time, and we are sending you our season greetings. Thank you.